so much for coming. It's an absolutely fantastic turnout for our 10th meetup. I want to also say that this is the first time when we're actually having a Zoom presentation of the meetup for people that can't come here in person. So I've been told to say hello to everyone on the camera, so hello. Another thing, we are incredibly grateful to AMPLYFI for putting this on. So all of the sponsorship that we've had and all of the drinks and all of the food that we're going to be having in the break. So many, many thanks to AMPLYFI for putting that on for us, and we couldn't have done this without them. So thank you very much. And also thanks to the venue, Tramshed Tech, for letting us use this. So I'll be honest, I have been incredibly busy recently, and I've rattled through these slides. So if there's anything like some wrong dates on it, I apologize in advance for those. So as we've just done, welcome to all our new members and first timers. So tonight we've got two speakers. We've just had a workshop in the room before. But we've got Timo Mulder from AMPLYFI, who will be giving a talk about building a custom text miner in a day. Then we're going to be having a break where we get a chance to have our refreshments and some networking. And then Vince Knight from Cardiff University will be giving the talk on game theory after that. Always like to start these events off by saying that we are one meetup amongst many in the South Wales area, which is fantastic. So we've got another team called AI Wales. They put on some great talks here every month. They've just had their October meetup, but keep an eye on it. If you want to go onto their meetup page and have a look for when they've got their next event, I presume it will be at the start of November. Cardiff are, unfortunately, Dave contacted me. He cannot make it tonight, but normally there's a guy, Dave, who runs that. It's a much more informal type of, not as if this is formal, but it's very informal in the sense that they just meet up on bar 33, which I always used to say opposite Buffalo, but I obviously haven't gone out for a long time because it's not Buffalo anymore. But you know, on that, what's the name of the street? Is it Windsor Street? Yeah, Windsor Street. So it's on bar 33 there. And it literally is sit around, they work with so if anyone has any problems with you're working with that, sit around, they just sit in a pub, open laptops, and they just talk about it. It's a nice informal event. PyData Bristol, we've got one of the lead organisers of PyData Bristol, Frank, who sat there. They have a monthly meetups at OVO Energy, which is very, very close to Temple Mead Station. The next meetup is scheduled at the moment to be October the 29th, but if you want to know more about that, have a chat with Frank and also become a member on their meetup page as well. PyDiff, the original Cardiff Python meetups, has been going for several years now. It's actually one of the first things that I started coming to when I was a mature student in Cardiff. And Vince, who is our second speaker, is one of the organisers of PyDiff. So have a word with Vince if you need to know. He's in the blue cap. Have a word with him if you want to know any more information about that. Also like to mention that we've got Kim from Interpeople. Kim, if you'd like to just put Kim at the back. So Interpeople is a recruitment agency in Cardiff. So if anyone is interested in finding out about the jobs market, have a chat with Kim in the break. She'd love to hear from you all. Okay, we'll start off with some news. Haven't got much this week because I have been incredibly busy, but this is quite exciting. So I don't actually use VS Code, I use PyCharm, but I really should go over and learn more about it because I have heard it is fantastic. They just announced that they're going to be having native editing of Jupyter notebooks in VS Code. So that got announced in the past couple of days. Also, I'd like to point out that this is the second conference that's going to be run, because the team at PyData London always run a conference every year. PyData Cambridge, which is another meetup similar to ourselves, running in Cambridge, but they're going to be putting on a conference as well. That's going to be running in mid-November. The very affordable tickets, so the tickets are still available. If anyone is interested, they're going to be in that area. You're going to get a chance to speak to some great people, of course, being in that location. Have a look at that if you're interested. So we always do a, not module of the month, but module of the every other month. And yes, we probably have used TensorFlow before, but I wanted to point this out because TensorFlow 2.0 is now released. So if anyone doesn't know, TensorFlow is one of those libraries that's used for deep learning, and it runs either on your CPU or on the GPU. But one of the things about it was sort of known to be quite verbose in its approach. And it's taken a lot of influences from a library called Keras, and a lot of the API has been updated to simplify it, basically. So have a look at that. That got released, at the end of September. Our membership, I had a look this morning, and it's gone really well. We've had a great turn up tonight, and also the membership's gone up. We are incredibly happy about that. It's now gone up past 800, so it's 825 as per lunchtime today. And I like to do these charts to see how the membership grows. It hasn't actually started falling, so I always take that as a positive. But we see here, I plot in whenever we have our PyData meetups there, and we can see that when we advertise them, sort of about 2 to 3 weeks before, that we get a nice uptick of members, and that is something that we are seeing is stable. So what we'd like to do is see if we can get to 1,000 by the end of the year. We're always looking for speakers. I'd like to stress that we've been doing this is our 10th meetup now, so you've probably seen that it's a very informal and a very friendly event. So if anyone's been coming, if you want to just give a talk here, please get in touch with us. Contact pydatacardiff@gmail.com. We normally put the slides on the GitHub page. As I say, I do have to tidy up the one. I need to put the slides in from the last time, but I'll make sure I put some time in to tidy this up there. But this is great for first-time speakers. If there's anything that you're working on where you're going to be giving a talk and you want to just have a practice run and get some friendly feedback, come along here and just get in touch. Honestly, we really want to hear from people and just give a talk. Don't worry about whether you think it's too advanced or too basic. We still want to hear from you. And we'd also like to point out is that Casper and I, if anyone does actually want to help out with any organization in PyData Cardiff, we've had interest from Ken. So, but it's anyone that can help out. It's just things like if you know of if you yourself don't know of anyone, if you know of anyone that possibly would like to give a talk, just helping out with some emails and stuff like that. Because these little things, they just take some time. So if anyone does want to help out, please just let us know. It's not much of a commitment, but just to try and help with our community. And we do have access for travel and accommodation assistance for people. If you know of someone that does need to travel in, we can help out with that. Or if anyone here needs assistance, if you're coming in to speak. We always like to mention that the PyData was set up by NumFocus. So NumFocus is an organization in America, and it works with helping to fund open code and better science. Because of course, a lot of these packages that we use, they're all open source projects. The people are not paid often for doing these things, and these developers need support. Because I think there was a scary statistic saying that it is a very low number of people that, if when they talk about the bus factor, if they were to be hit by a bus, there's not that many people. I think it's below 20 that are sort of the core developers for many of the key scientific packages that we're all using in Python. So NumFocus is one of these organizations to try and give these people to support, and also try and get more people into that to try and develop and use the code, use all of these tools that many of us use for our daily living. So we always like to mention that you can become a member and you can make a donation through that. Anyway, enough of me talking. Let's move on to our first speaker. So please welcome Timo, who's going to be talking about building a custom text miner in a day.
Thank you all for coming today. Before I start off, I should probably tell you that I usually get very nervous for presentations, so especially if it's about 100 strangers. Yeah, this time I tried to really challenge my stress by thinking like, what's the worst that can happen? Well, there's a lot of things you can come up with if you're thinking about what's the worst that can happen. So in the end, I decided, well, if may the worst happen, I can always jump on a plane, right? And just forget about all the people in Cardiff. That was until my colleague came to me about a week ago, and they told me that they were gonna film it, live stream it, and put it online afterwards. So I guess it just better be good, you know? So yeah, about me. Can everyone hear me clearly, by the way? Okay. About me, yeah. My name's Timo Mulder. I'm not Finnish, as many people think. I'm Dutch. And I'm also not a supernatural detective, if you've heard of X-Files. I'm actually a senior machine learning and natural language processing scientist here at AMPLYFI. A couple of years ago, so before I started at AMPLYFI, I did my master's in AI at the University of Edinburgh, where I combined machine learning, natural language processing, data engineering, and human-computer interaction. And I was even able to combine a bit of everything in my thesis, which was indeed pretty long in the end. Even before that, I did my undergrad also in AI in my hometown at the University of Amsterdam, which touched a bit of many of the subjects in artificial intelligence and has a great balance between technology and cognition. So let's get on with it. Building a custom text miner in a day, that's the challenge my colleague gave me a couple months ago. And here's a little story about what I was able to come up with. So what happened? My colleague came to me and challenged me to get some key findings on a number of documents. He mostly wanted the results to look like in such a way that he could potentially make like a word cloud out of it to show like the key findings. Yeah, he challenged me to come up with some key results within a day. What he had available for me were a large number of URLs to annual reports from several companies. Of course, they were in Excel, which is, well, not necessarily great, but I heard in the workshop, they actually went over it, that you can easily load it in Pandas. I didn't know that. But yeah, it's good to know how to deal with Excel because many business people and customers use Excel. Yeah, so what my colleague would like to see were some key phrases per document, maybe the companies that appeared in the documents, and they had these phrases had to have some sort of weight or prevalence because they had to be able to fit in a word cloud. So yeah, I immediately started to think about possible methods that I could use. Because I only had a day, I of course had to come up with some simple methods, methods that were easy to implement. My first thoughts were actually to use a method called TF-IDF. This stands for Term Frequency Inverse Document Frequency. When you're using this method, you have to be very careful about what your corpus is, because the inverse document frequency part makes things that occur in many documents come out lower, and in few documents come out higher. But anyway, I will go into detail later in this talk about that. So yeah, I needed to know what this other set could possibly be and what the possibilities were. And so to find out about that, I asked my colleague some questions. So what I asked was whether he was interested in the relations between the companies, because there were company reports of several companies, or whether he was interested in the data of one company, but between all the years of the annual reports. And of course, yeah, this helped me shape which methods were in the realms of possibilities. And of course, another question I had was, dude, what's up with this deadline? And in the end, I got a little more time, but today I will talk about what I was able to come up with within a day. So in the meantime, I started building a rough pipeline. So I had to start with data preparation. So first I had to download all the documents, which is also known as scraping. Then I had to retrieve the actual text. It was in PDF format, which is relatively unstructured. So I had to extract the text out of the PDF format to be able to process. And data from the internet is quite noisy usually, so I also had to do a bit of cleaning. And then the next stage is the data modeling part. Feature extraction means refers in this case to getting the key phrases and companies, and it's generally a term used for getting structured data which you can then feed out of your maybe unstructured data, which you can then feed into your model. Yeah, and finally, of course, I had to do some sort of filtering or modeling or ranking of the sorts to produce the results. So yeah, I should note that everything I programmed was either written in Bash or in Python. And by the way, I also thank my partner who's sitting here for the beautiful rainbow. That was her idea. So yeah, the first stage is data preparation, which was scraping, extraction, and cleaning. Just gonna take a sip of water. Sorry. So because I didn't go to the Awesome Pandas workshop this afternoon, I chose to convert my Excel files to CSV. So yeah, I could easily read the CSV files using the CSV reader. It's a Python built-in function, but you can also just use string.split because CSV stands for comma separated values. After that, I had to download the docs. So to download the documents, I used the Python request library. I really love this library, and I think it's the go-to library for doing any sorts of HTTP requests because it's very simple to use, but it's also quite powerful, I think. And yeah, at first I actually had a bit of trouble to download some of the documents. I was suspicious that it might be because the service I was downloading from might detect that I was in the browser, but that I was actually just running this as a bot. So what I did was I opened my Chromium browser and I looked up whatever Chromium was sending off to web pages I opened and copied these headers straight into the Python script to pretend my Python script was a browser. And that helped actually, but then I still got a few certification warnings or errors actually, and to overcome this, this is actually because Python doesn't have like these default certificates that browsers have. So to overcome this, you can either use the certify package or you can just turn verified to false, which I, of course, not recommend as much. And this way I was actually able to download all of the PDFs except for the ones that were taken down by the company already. Yeah, so once I had all the PDFs on disk, I had to get the actual text out of the documents such that I could start processing. And I also did a little bit of cleaning by means of paragraph deduplication. So like I said, all of the documents I retrieved were in PDF format. And I personally both love and hate PDF format. I love it because it's super universal. So pretty much any operating system can read any PDF produced by any other operating system. And also Adobe doesn't ask any royalties for it anymore. It's been implemented in an ISO standard, so that's all great. And also what I really love is that you can just save things in vector format. So you can get infinite resolution images and because you don't necessarily need to rasterize your images. The downside is that it's basically vectors. So text is basically just drawn from characters on a canvas. And that makes it really not easy, not straightforward to extract text from the documents. And actually some PDF extractors even have problems to separate certain characters and words. And yeah, the biggest problem is getting proper paragraphs, leaving out the page numbers, titles, proper line ending, and don't even get me started on the tables. Again, it's pretty much a drawing. And yeah, it makes it quite hard to extract text. Sorry, I'm not so good at remembering all this, what I wanted to say. Oh yeah, so then I quickly had to decide on a text extractor. So I first looked up this open source Python PDF extractor called PDF Miner. It's supposedly very good at keeping the original structure out of the PDFs, which I'm sure it does, but it's also extremely slow. So since I didn't have much time on my hands, I definitely wasn't going to wait more than an hour for my documents to be extracted. So I just did a quick comparison, and I looked into a Unix package called PDF2Text. I think it might actually also have some Python bindings, but and this was actually almost as good, and it was really fast. It was pretty much instantly. So yeah, now I have a question for you all. Does anyone know which language this is on the right? Neither do I. So for some older docs, the PDF to text just only extracted gibberish, unfortunately. Possibly they had some different encoding, or maybe they had some encryption. But luckily, because these documents were quite old, I didn't have to put much priority on getting these extracted as well. And as you can see for other documents, I don't know if you can read this, but PDF to text actually did quite reasonably. Although it's consistent with the text, it would have been nicer if it didn't put a break here, of course, because it's the same sentence. And oh yeah, so to further clean the text, I also applied a method called paragraph deduplication. I should probably explain a bit what I mean by paragraphs. By paragraphs, I mean everything that's separated by a white line, so a double new line in coding. And here, to confuse the things even further, I separated them by a red line. Paragraph duplication, I do that to remove things like headers, titles, footers, but also all sorts of other things that just replicate a lot in the text documents, but that we're actually not, which we definitely don't want to be extracted by our final phrase extractor multiple times. So for example, here you can see in bold font, Acme Things PLC annual reports and accounts 2018, which was the footer of some document. By the way, Acme Things is a fictive name. And yeah, we don't want like annual reports and accounts to be extracted every time. So we just deduplicate it. So yeah, in this particular document, actually, Acme Things, the phrase I just showed you was the second highest scoring. I think anyone in the audience can take a guess how many pages this document had. It was about 140. So, yeah. So if we would have kept these phrases in, this might have cluttered the data quite a bit. So let's get on with the real deal. So the first thing to do is feature extraction, which is just a fancy phrase for getting the interesting bits out of the data. Or more formally, retrieving structured pieces of information that will be useful to the model. So yeah, I mostly focused on key phrase detection and also a bit of normalization. And I also extracted entities, but unfortunately, I don't have much time to go into that today. So yeah, the reason that I did key phrase extraction rather than word extraction is because I think phrases tell you a lot more than words. They give a lot more context. For example, I personally think that store doesn't mean that much on its own, neither does cost. And I think they individually mean, definitely don't mean as much as store cost. If you have store cost as a phrase, I think you can actually already start thinking about a narrative around it, right? So, oh, probably this company had to cut down on store costs this year, or maybe store costs went up. So you definitely get a lot more context than just store and cost individually. So what I did was I did some n-gram extraction. So n-grams are phrases of length and words, and are commonly used in natural language processing. Part of the reason for that, they just give a lot more context than the individual words. And I cheated a bit because I used AMPLYFI's regular n-gram extractor, which I actually wrote about 1.5 years ago when I just started AMPLYFI, and which also performs some normalization, such as stemming, and stop word removal, such as the and. And I also did a bit of grouping to reduce sparsity. Sparsity in this case means low frequency n-gram count, n-grams with low count. And yeah, I'm sorry that I wasn't able to tell you more about this algorithm. I think it's quite cool. But if you really want to know more, then you should just come apply and work for us. Yeah, so now for the actual data modeling part. Yeah, my colleague asked for some sort of weighting or prevalence, and the most simple but poor thing to do here is to simply count the phrases. So just get the most occurring. That's actually quite a poor idea, and I will show you in a minute why that is. And I also show you that quite a simple but better method to use is called TF-IDF. And as a bonus, I also did a bit of, I also used the top-down approach, which is where I just search for specific keywords that were given to me by my colleague. Yeah, like I said, my colleague wanted some sort of prevalence, and a poor thing to do here is count. Sorry, I'm in front of the screen. I personally think this image says it all. These are clearly not really the terms that anyone is interested in if you give a bunch of annual reports and expect to get the key findings back. I mean, financial statements is pretty much a description of annual reports, right? Yeah, they don't tell us much other than that they came from this document from Acme Things Annual Reports and Accounts. Yeah, and sorry. Luckily, we have more than one document per company, and this will come in handy in the method, the TF-IDF method that I will start talking about now. So, like I said at the beginning of my talk, TF-IDF stands for Term Frequency Inverse Document Frequency. The more often a term occurs in a document, the more importance it has to a document. However, this number is scaled by the total amount of documents it occurs in. So, for instance, a phrase like annual report will occur frequently in a given document, especially if we don't do paragraph deduplication. But it will likely also appear in all of the documents, right? So in the end, because of the inverse document frequency, we will give this document a low value. In fact, if we have a look at the formula, especially the second part of the formula, DF, so the log part, DFT here stands for the document frequency of the term, and N is the total amount of documents in our corpus. So if the term occurs in all of our documents, then DFT would equal N. So that part of the formula would become log 1, and the logarithm of 1 equals 0. So the whole term would get a weight of 0 because it occurs in all the documents, so we say it's not interesting. So yeah, but because, like I said earlier, because of the inverse document frequency value, we need to choose our corpus wisely. Take the example in the case that we would have computed TF-IDF for one particular year, but over all the companies. So if all the companies talk about the same thing in that year, for example, online competitors, this term would get a very low count. But it might actually be a potentially interesting term, especially if all the companies talk about it in one given year, right? And vice versa, if companies, like company-specific terms like Acme Things annual report, would get a high score because that's company-specific. So that would not occur in all the documents if we do it across all the companies for 1 year. So in the end, I decided to do it for, I specifically chose to use one company and measure TF-IDF over all the years such that we get the key events per year for a particular company. So yeah, the bonus exercise, because I finished the task a bit earlier than expected, tip, never do that. They asked me to count particular words such as acquisition, growth, and risk in the documents. And I did what I was asked to. I gathered percentual counts of all the words. But I also asked my colleague whether he might be interested in getting if I looked up these keywords in the key phrases that I already extracted to, again, give a bit more context to these things happening within a company. And oh yeah, to find as many many phrases as possible, I also did stemming on these words, such that well, it's not actual stemming, but I just created like the shortest form possible. So I made from acquisition, I made acqui, such that also acquired and acquiring or acquire would also be captured without me having to write all of them up. And yeah, now that we also captured the key phrases, we can actually also see what kind of growth or risk or acquisition has happened within the company. So now for the results. Let's first have a look again at the results where we just did a count. Notice how high these counts are, and also notice how relatively low the TF-IDF weights are. Yeah, like I said, some of these TF-IDF weights have actually dropped to 0 because they occur in all the documents, so they are not interesting. And let's have a look at our new top scoring phrases. I should probably start by explaining a couple of the terms that we see here. Ernst & Young did the audit of this particular annual report. Jane Doe is a fictive name, clearly. It's the CFO, it was the new CFO of the company that year. Also note how the people who were already in the other documents weren't mentioned. So the CEO was not new, so wasn't mentioned. A quick Google search taught me that onerous lease charges is when it means that when the store produces less value than the lease costs, but I'm sure there's people here who know better than me. and AIM is a London Stock Exchange. And I personally think it's clear that these terms are far more meaningful and central to the document than the ones that I showed you before that were ordered by count, which look very general. And also notice how relatively low these counts are compared to the previous one, where the counts were in like almost 40 plus, and here they're like between 5 and 11. And yeah, now the results of the bonus exercise. So on the table on the right, you can see that this company for that particular year clearly had to deal with a lot more than just the principal risks. They also had to deal with risk of fraud. They had to deal with foreign exchange risk. And although this doesn't tell you the complete story, I think that definitely does give you a lot more context than just the percentage of risk. So, and my colleague agreed actually. So, at the bottom, one particular phrase I came along, which I quite liked in another document, was digital growth. And I thought definitely that one gave a lot more context than just growth. Yeah, so what's still missing in this data? Although these phrases give a lot more context than just individual words, I still had to go back into the document to actually find even more context about this term, and to know why these terms scored so high. So to overcome that, what you could do, and things we also actually do quite a lot here at AMPLYFI, is we could do relation extraction. A simple thing to do is, for example, the term co-occurrence. So we could see how often particular phrases co-occur in the documents or in other documents as well. And other relation extraction you could do is, for example, also between phrases or terms and numbers. We could look up, because then we would have found out how much onerous lease charges the company had, which I totally know what that means. And yeah, some additional filtering might have also helped. So my colleague gave me a few terms to look up, but vice versa, we could have also used the list of terms to do more filtering or be smart about it. And finally, we could have done traditional topic modeling. And topic modeling is commonly known as clustering words or phrases. The simplest one of these is called k-means clustering. Here you create k clusters and you try to find the nearest vectors for your clusters, and this way you can make like clusters of words or phrases. I think the most famous one is latent derision allocation, LDA. It's personally not my favorite because it's sampling based, it's probabilistic. So basically, yeah, it's non-deterministic. So every time you run it, you might get a different outcome, which usually, if you deal with clients, they're usually not very happy about that. And the other reason is that it's relatively slow. You have to train it, and it's also domain specific, so you have to retrain it for specific corpi. And I think one that's a bit in the middle here is called non-negative matrix factorization, which is basically dimensionality reduction. So you can decide how many dimensions or topics in our case you want, and you can sort of yeah, it's sort of similar to the k-means clustering, but it's a little more it's like linear algebra based. So what are the conclusions we can draw? I think one of the conclusions we can draw from this talk is that Python, or actually from my exercise, was that Python is ideal for a quick scraping of documents. And not alone that, it was also very useful to write quick scripts to do all the document processing and extraction. I think we can also conclude that PDF is a beautiful format, but it's really painful if you want to extract the text out of it later on. And I think a recurring theme in my talk was also that n-grams say a lot more than words. They give a lot more context. And if you don't want to just sort by count, then TF-IDF is very simple, quick, and powerful algorithm to use to get quick insights into your data, but you have to choose your corpus wisely. And finally, like I said in the slide before, I think further steps are possible and also necessary if you want fully automated reports. This is actually what we spend a lot of time here. We spend a lot of time on here at AMPLYFI. And we've produced several of such solutions in the meantime. And yeah, that's it. Thank you all for listening. And let me know if you have any